So I'm Jon Hunt, and I'd like to thank very much for the opportunity to come and speak to you all today. As was explained, I work for Toyota. I'm probably what you call a veteran of Toyota. I've managed to stay there for some 30 years. And in that time, I've seen quite a lot. I work in the fluffy side. I work in sales and marketing, unlike my colleagues who make the stuff. But guess what? You need us to sell that stuff. So, you know, it's about collaboration and cooperation. I'm going to give you a bit of a background to what I've learned and what I've seen in terms of perhaps lean product problem solving in those years. A little bit different than the academic things we might have heard today, and perhaps some resonant things about what we're all experiencing in environment and other areas. So here we are. We're problem solvers, aren't we? So we're problem solvers, and we're trying to get to that silver bullet. I'm perhaps sort of a bit overawed by the people in the room, the things that people have done, what we've learned about how they've managed to achieve things and how they've managed to progress things. You know, this is a room full of, well, I have to say there, practitioners of problem solving. And in fact, that's one of the innate human things that we all have. The very unique thing, in fact, that humans have in the animal kingdom. We can think of things in the future, and we can modify the environment that we're in, and we can take action to address that. So, you know, when you were thinking about the sunny weather here in Liverpool, I'm sure you bought your sunglasses because you knew it would be such glorious weather. You think about that when you travel, when you're going to plan your journeys, what you're doing. So this is what we do. This is what humans are able to do. And you know, there are a lot of people out there, lots of gurus who will help you talk about these sort of things, futurologists and stuff that will help you do that better. But my presentation is about the future of mobility, and perhaps I'm doing myself a disservice, but the truth is, quite frankly, nobody knows the future. Nobody knows what is going to happen in the future. It's a simple fact. It's rather like a lottery. And really, the only thing that we can be certain about is uncertainty. That is the only thing that will definitely be the case for the future. So how do we actually address that? How do we work around the problems that come up, and how do we understand how to mitigate those problems? Well, one of those things is, say, to standardize process. Think about what's happening and do certain practices that help shape the future. So legislation, for example, can force the direction that we go in. But really, in order to address those problems, you need to think of it much more broadly, and how you might address those future unknowns. And we've got a great example of how we can address and think about these things, and that comes straight from nature, because there is no better example of how to address problems, how to work in an environment that changes than nature itself. Because after all, when you think about it, nature doesn't choose one very best species of animals or special species of plants. Nature has developed in diversity. It has evolved and adapted in the environment that it's in. We talk about ecosystems, interwoven ecosystems, in balance and in harmony, because if it wasn't, they wouldn't exist. This is what happens. Things die out. So it's balance and harmony that allows us and animals to live in a way that is sustainable and has a future. Our great talent as humans to be able to adapt the future causes a few problems, however. Because, let's face it, we are managing to adapt the environment around us to live in places and do things that we oughtn't probably to do at all. Colder climates, hotter climates. We've managed to grow our populations with fantastic medical science helping us along the way. But the problem in doing so is, of course, we're putting things out of balance altogether. We're having an impact on the environment, in the fuels that we use, the carbon issue, the climate change, how we manage these resources, and indeed, you know, how the equity of that is. Because it's not the same around the world, is it? We're all in different circumstances, and this is all to do with our fantastic innovation and problem solving. So perhaps we have to take a different approach in how to make it actually sustainable as we go forward. And one of the most fundamental things and one of the most damaging things, of course, is energy. So I would argue that probably the one great thing in the sense of helping humans develop was enabled to harness energy. Harness energy to use it where we want. By harnessing energy, we were then quite simply able to do the things that we wanted to do on top of what we had to do to survive. But in doing so, of course, we've created a lot of damage. But we're pretty lucky. We're pretty lucky because if we think about nature's energy store is hydrogen. Hydrogen is what powers the universe. It powers, in fact, the very sun that we have around us. Though the sun gives us the energy for our crops to grow. Our crops feed our animals. That relationship from the energy that's going in is what helps us and our animal kingdom, if you like, survive and develop. The sun provides us with the energy that produces those crops, that produces those animals, that incidentally produces all our fossil fuels. And indeed, the sun also provides us our energy for our photovoltaic energy, our solar power, our wind, indeed, as well in the climate that it produces. Hydrogen is the key constituent of water, and without water, we wouldn't have life. So, if you look at it in the round, hydrogen is the essential driver for the environment that we all live and thrive in. And the great news is, in fact, we have no problem whatsoever in terms of energy on Earth. In fact, in the universe overall. Because 75% of the mass of the universe is hydrogen. It's inexhaustible. It's entirely renewable. It's not toxic. It doesn't cause us any damage. So therefore, this is the source of energy that we can all utilise. And in fact, it is the source of energy we utilise right now, all the time. Because if you look at the energy that we use, our coal, our gas, our oil, even our biomass is based around hydrogen. The key energy vector in everything that we use is hydrogen. The problem, of course, if you have a little closer look at that chemical formula, is that the energy that we use is all bound up with a lot of polluting, toxic, dangerous, and altogether unpleasant other molecules and elements. The carbon that causes the issues that we have. So this is a huge issue. So how do we overcome it? Well, it's not going to be easy. Because when we look at energy, over 70% of the energy that we use on Earth today is based around those fossil fuels. So weaning ourselves off it is going to be extremely difficult. So we have to take different measures in order to get new energy or somehow clean up this energy, get rid of some of that pollutant that's in our energy that we currently take for granted. And again, this is fantastic because our hydrogen-powered star provides us with the opportunity to take energy and turn it into something which is clean and completely renewable. Because, of course, the sun creates our weather patterns. Our weather patterns produces wind, and that, in fact, has, through its effect of warming the sea, creates our currents. And those currents provide us with the power that we can also harness as well. And it's inexhaustible. There's more energy lands on Earth every day to run the Earth for more than a year. The problem, of course, is this energy tends to be in places which are remote and difficult to get to. So the best wind is in the middle of the sea, the top of a mountain, the best solar perhaps in the middle of the desert, far, far from the places of consumption. So how do you move that energy? How do you get that energy to where you actually need it? These are the challenges for problem solvers, really fundamental problem solvers in the world today, because we need to do it renewably. You know, in all of us, and it doesn't matter where you are, in the UK or around the world, I would guarantee that you are paying in your energy bills for wasted energy. Energy that's produced right now that we can't consume. I find it remarkable that at home I have a green energy tariff. And at home, I have electricity, I have a gas fire, and I have a gas oven. When I turn on my gas fire, apparently it's green, because I buy that with a tariff. When I turn on my electricity at the middle of the night when the sun's not shining or the wind's not blowing, apparently I'm buying green energy. Surely that can't be the case. The sun's not shining, the wind's not blowing. Where's this green energy magically coming from? I'd argue completely different, probably they're a completely different audience, about the madness of how we accept this to be the case. We don't think about it. We don't think about where energy comes from. Energy in our energy grid isn't even a grid in the sense of we're all got the same collective energy. Where our factory is in Burneston, there's a gigawatt valley. It's got a huge coal power station down the road. The other day when I looked at the energy in the UK, which is made up, I think it's about 15 different areas our grid is made up of. If you're in Scotland, your impact, your CO2 impact of the electricity was zero. The wind power allowed you to take zero CO2 energy from the grid. In Derby, it was 460 grams of CO2 per kilowatt hour. What does that mean? If I was plugging my car in Scotland with my battery, fantastic. Zero tailpipe emissions, zero from the energy. If I was plugging my battery electric vehicle in Derby, it was dirtier than the hybrids, the petrol hybrids that run off the factory forecourt. It's not the same. So you've got to understand energy, where it comes from and how it's used. But we have ways to manage things. And an example I would give, were I running a farm and I had my tomato farm, if you think about that, you want to maximise your efficiency. So you maximise your efficiency by growing your tomatoes 365 days a year in massive quantities. Fabulous, because that means if you like tomatoes, you can eat tomatoes, your heart's content. Great. But I would argue that at some point in time, you've probably had enough tomatoes. So what happens with all those tomatoes that are being produced and not consumed? Very straightforward. Because you can store them, and you can store them indefinitely, and you can store them in different ways. I can make tomato juice, I can make tomato paste, I can peel them, I can chop them, I can slice them. I can give you tomatoes all the time, anytime, everywhere. Can you do the same with energy? Well, I think that many of us can't have escaped the push to electrification. Battery storage is one of those solutions. But let me just say, battery storage is about short duration. We know from the phones we carry in our pocket that batteries degrade in terms of energy performance. These graphs, without getting too much detail, these graphs are from the Faraday Institute and other research bodies. So these are independent analysis of what battery material, or battery production, and use is likely to be over the next up to 10 years or so, or longer. So the graph on your left is for, I'm going to get this to work. Yes, I think I can, although not very well. I'll give up with that. So what you're seeing in these two graphs is a similar thing. One is for the world, one is for the UK. And the analysis says, what sort of battery materials will we require? What sort of battery production will we require until, in this case, up to 2030? And the thing to draw your attention to is everything apart from the black bar at the top is about mobility. And that says that we will require a certain number of batteries to produce all the vehicles that we produce today and all the manufacturers want to sell. We've all heard manufacturers talking about gigaplants, talking about how they're going to drive their electric revolution with all this production, and they know they sell a certain number of vehicles a year. We know we have a certain number of vehicles outside in the world, so you can estimate quite reasonably what the potential requirement would be over the period. And in the other graph here, this one actually is the same for the UK. And it's very similar. Everything apart from the very top, in this case the grey bar, is all about energy storage for vehicles and transport. But strange in my mind, because actually the biggest requirement of energy is not transport at all, it's heat and power and industrial processes and so on. So actually there's a big bit missing in this, but let's just follow what the researchers and so on say. What they say, Benchmark Mineral Intelligence, who produces material, produces some of the world's best insight into materials for batteries and raw materials. What they say is that what we require in order to fulfill those battery requirements purely for transport is we need about $360 billion and we need about 360 new mines in order to fulfill that requirement. However, they also point out that if you were to know where these materials were and you were able to start your mine and dig it up and go through your processes, it will take you between 10 and 15 years. And guess what? We're in 2024 now, and by 2035, when the UK and many other countries will ban combustion vehicles, we're expected to have produced that many batteries. There's a bit of a gap in terms of where you think the production of batteries may be. And that's actually understood. So despite all the things that are talked about, it's very well understood. And the other question we've got to consider is where and how battery production is done, who controls it, and will it be available to us all. And these tables really just show you just the current situation. So this is battery production, this far graph here. This, draw your attention to the red block, is battery production in China. Great, China produces a lot of batteries. They have a lot of demand themselves. Are those batteries really going to be made available at a price that's achievable and affordable for the rest of us to do the things that we want? We don't know yet. If you look at the far side, this is actually looking at the material production side and who controls what, the minerals and also the production capabilities. And China dominates it entirely. When we look at all the materials and minerals, it's already identified that for Europe alone, we've got, by 2035, a 78% shortfall in the cathode materials. We've got 700,000 tonnes of graphite shortfall by 2030 in Europe. So there's a huge gap in terms of raw materials and the batteries we apparently require. And when we look at costs, we should look at that and understand how costs are made up. Over 50% of the cost of a battery is raw materials. If you are rushing to get those raw materials and they're in short supply, it's unlikely the price is going to go down. So the only place that you can play around with in terms of the cost of batteries is with the manufacturing process, and perhaps by making your processes very lean, you can reduce the costs in some way, but you're not playing around with an awful lot of fat in order to take out of the system. So how might you address it? Well, there have been people thinking about these problems for a very long time. So in 1870, this gentleman, Jules Verne, had a thought or two.
I believe that water will one day be employed as fuel, that hydrogen and oxygen, which constitute it, used singly or together, will furnish an inexhaustible source of heat and light, of an intensity of which coal is not capable.
Now, he had no idea how this was going to do, and despite my sort of comment about nobody knows the future, people do have insight and can give you some direction. And so here we are in 2024 thinking about what we could do with hydrogen. And in fact, it's not just started now. It's been going on for a very long time. But in terms of hydrogen itself, you've got to understand a little bit about the chemistry and how you can extract hydrogen and how you can use it. Now, one thing you can do with hydrogen is you can remove the impurities from the fossil fuels that you've got at source. Carbon capture, use and storage. These are the things that we hear about now. These are technologies which are possible. But the ideal situation, frankly, is to use water, because water is H2O. So it's got a large amount of hydrogen and it's got oxygen in it. And if you put energy into water, as many of us will have done in our chemistry labs in the past, you can split that hydrogen and oxygen apart. So you've got two different parts of that which you can use in different ways. And the principle is really quite fascinating, because when you use hydrogen, the only thing you do is produce water. So, for example, if I need to fill my hydrogen-powered car, my Mirai, I need 5 kilos of hydrogen. To get my 5 kilos of hydrogen, I need about 50 litres of water. I put some excess renewable energy, that energy that we're not using for everything else, it's free energy. It's already been invested in 1 terawatt energy that so far this year in the UK we haven't used, that could power certainly the UK for a day, that energy that we're wasting, turn it into hydrogen. So you put your energy into water, you produce your 5 kilos of hydrogen, I put it in my hydrogen car, and I can drive my car 400 miles or so on those 5 kilos of hydrogen. The brilliant thing is, the only thing other than that energy that's come out of that I'm producing is 50 litres of water. The same amount of water that I started with, I end with. The process is all about energy transfer. It's exactly what happens in all the plants around us in photosynthesis and the process of energy transfer. This is a completely organic process, and it can continue and continue and continue without any impact. And we can use that hydrogen in the same systems that we currently employ today for transporting energy around the world. But we can produce that energy in the right places, and we can move that energy maybe as hydrogen gas, or maybe as a hydrogen carrier, ammonia, methanol, and so on. And so we can ship it and use it in the different processes that we need. And we use hydrogen at large levels right now around the world. So we can decarbonise our heat, we can decarbonise our power. Hydrogen is a molecule. Hydrogen is essential for the production of certain things. Fertiliser, for example. We wouldn't have the food that we eat today if we didn't have hydrogen. So therefore, you can use that commodity in many, many different ways. Now, Toyota is, like many companies, a company of innovation. In fact, founded on innovation and problem solving. And it recognises the problem of sustainability, because just like all of us, if we destroy the environment we're in, then there's no future for anything. And it's, quite a profound thought. So as a business, we've always had different environmental plans. Those environmental plans have accelerated and developed over time, but the 2015 plan set out our plan to 2050. And that plan talked about a couple of things. And the key thing, I think, is that we realised that something called net zero, is pretty meaningless. What does net mean? What really does net mean? So you can only have something you can measure. And what you can measure to zero. So let's say 0. That should be our target, 0. That makes an awful lot more sense. And once you can get to 0, or alongside your process of getting 0, you can do something better. You can become net positive, I think is a reasonable assessment. So the water that goes into your production processes can be cleaner when it comes out. The air that goes into your vehicle or your other process can be cleaner when it comes out. The raw materials that you use can be reduced as you go through your processes. So you can become a net positive contributor. Now, transport itself, the future of transport. Well, if you think about transport, we talk about 0 tailpipe emissions. Really, that's the thing we talk about, 0, and that is an ideal situation to achieve. But in order to make an electric vehicle, you need 3 key constituents. Whatever electric vehicle it is, you'll have your wheels and bits and pieces, of course, and your designs of vehicles will be different. But the 3 things you need are a motor, a battery, and some sort of power control unit or inverter. And then you can turn them into different types of electrified vehicles. So you have hybrid electric vehicles, and those hybrid electric vehicles turn their petrol into energy, electricity, to drive your vehicle. And they can drive down the emissions by 1/3 or more. And this allows you to improve the performance of the vehicle you've got in. If you have a plug-in hybrid electric vehicle, you can put a larger battery in, and you can do the same with your hybrid systems. But you can also take a little bit of energy that's made on the grid with their emissions elsewhere to reduce your tailpipe emissions where you're actually using a vehicle. A battery electric vehicle, well, clearly with a battery electric vehicle, you're taking all your energy produced elsewhere with its emissions elsewhere, and you're driving 0 emission all the time. A fuel cell hybrid or a fuel cell electric vehicle is actually a hybrid vehicle as well, and that works in the same way. It has its power stored on board, or its energy stored on board as hydrogen. It converts it into electricity and gives you a drive. So these are different ways you can electrify vehicles. There is another thought that you have to consider though. The total resource content that we touched on before. So you've only got a limited amount of resources. So how do you use those resources in the most efficient way, in the best way? It was mentioned the other day in terms of a simple mechanic, but with my batteries are batteries. Pretty fundamentally, so I can make one large battery or many small batteries with the same amount of material. It makes a lot of sense to make many small batteries, really, because with those small batteries, you can put them into different types of products. Most of us park our cars up most of the time, so making one big battery for one person surely solves one person's problem, but why don't we spread those batteries and give people the opportunity to do many more things with that same limited battery resource? You've got to think about the energy. Whatever energy you use, whether it's petrol, diesel, gas, hydrogen, or electricity. You need that energy on demand. It's got to be delivered to the vehicle as and when you need it. Using stored energy in hydrogen allows you to do this both for electric vehicles, battery electric vehicles, and fuel cell vehicles. And when it comes to renewable recyclability, then in fact batteries are extremely difficult to recycle. We should try and avoid as much as possible, and therefore we should look at other alternatives. Fuel cells are almost 100% recyclable and recoverable. So from a Toyota perspective, the view is multi-pathway, just as in nature, a diverse range of products to satisfy different needs at different times and transition along with it. And the fact is, unless you have carbon neutral fuels, you do not have carbon neutral transport, whether it's a battery electric vehicle, a fuel cell vehicle, or anything else at all. And the roadmap for Toyota has not changed. This has always been talking about different types of fuels and different products for different requirements, because customers decide what they need, and you need to satisfy it in the most sustainable way. So a fuel cell, very, very briefly with no chemistry, this is a fuel cell. This comes out of our cars. In our cars we've got 330 of these, and in very simple terms, this is like a sieve. And on one side you have hydrogen, and the other side you have oxygen. And what happens in here is that the protons in the hydrogen, which the simplest element, one proton, one electron, are forced through this fuel cell onto the other side, and then the electrons are released. And the electrons are released and want to join up with the hydrogen protons on the other side, simply because oxygen from the air is attracting them. Because hydrogen doesn't like to be on its own, it likes to join up with its buddies oxygen and create water, H2O. That simple process can carry on indefinitely, and you can put these systems into all sorts of products. You're producing water, clean air, and energy when you run fuel cell vehicles. So what's been the barrier? The barrier is quite simple. The barrier has been how to store enough hydrogen to be able to produce, to drive these vehicles in a manner which we all need. And this is actually a very interesting historical relationship. Because in 1906, Sakichi Toyota developed the circular loom. And the circular loom was a very fine loom. It produced in great cloth. But that same technology could be used in our carbon fibre weaving looms. And so from that development, we were able to develop the carbon fibre tanks. Because of course, that hydrogen has a lot of energy in it, and you want them to be safe, and you want to be able to carry a lot of hydrogen. And this is our tank. And often I'm asked, what happens when that hydrogen leaks? What if it gets a hole in the tank? Well, I'll tell you, it's very difficult to put a hole in the tank. But one way you can put a hole in the tank is you can shoot it, if you should have an armour-piercing bullet. And if you look at the little video at the side, you'll see what happens. Bullet goes in, gas comes out. No drama, no explosion, no issue. Of course, it's got energy in it, but that will dissipate extremely quickly. So it won't explode. It isn't a problem. And one other question that's often asked is about the systems and systems efficiency. Of course, to produce hydrogen you need energy. If you've got excess energy, then okay, you're using spare energy, it's not a problem. But don't be confused. Energy efficiency is not the same as thermodynamic efficiencies. And energy efficiency in vehicles is about weight. And weight in fuel cell vehicles is far, far less than a battery. So in the case of our fuel cell systems, same components with the additional fuel cell equipment, it's around 200 kilos. A battery, to do that same performance, over 500 kilos. 500 kilos of dead weight carrying around. That's muda, that's waste. That's not what you want in your vehicle at all. So that's what drove Toyota to develop the first fuel cell vehicle. So this was launched in 2015. I was fortunate to sell, in fact, the first car outside Japan here in the UK. And we followed that up with the second generation car, much more contemporary, longer range, higher performance. The beauty of fuel cell systems, though, is that they can be used in different ways. So this is our bus. This is in London. This bus has exactly the same fuel cell as our car does. So you can use the same equipment to do different things. We've just completed a project in Burniston, our production plant in Derby, which is converting the pickup, very difficult to decarbonise pickups because of the job that they do, using exactly the same fuel powertrain system as we have in the second generation Mirai. And our aim is to bring that car to market if there's demand, because it's customers that actually drive what you will produce. And we're not stopping at all there, because a fuel cell simply generates electricity. So anywhere you need power, you can do different things. So our systems are already being put into rail applications, maritime applications, stationary generators. I have one up in Derby, which is I'm using from our stored hydrogen energy to charge electric cars. So this is something that we can do across the piece. Now, Toyota is a company of innovation, and we're often asked why we're laggards in electricity or what people perceive as battery electricity, but far from it. And you should understand it takes a long time to produce things. Over 60 years ago, we started our hybrid development systems, our hybrid powertrain development. 60 years. There are some manufacturers who are just introducing their first vehicles. So, over these decades, we've produced we're producing large amounts of vehicles, around 11.5 million a year last year. There are around 300 million Toyota vehicles on the road today. We have a lot of experience, a lot of understanding that we need to satisfy a lot of different demands around the world. So that brings us full circle. That says, as we know, nobody can predict the future. It's a little bit of a lottery. If it weren't, we'd all have won that lottery and we probably wouldn't be here today. But it takes people with insight to tackle those problems and think about the processes in which you can moderate and control that uncertainty as we go forward. So, I finish. Have you ever seen a werewolf? But I guess we've all been asked for silver bullet answers. But there are no werewolves, and there are no silver bullets. The only thing we can do is try and think about the problems that we have and how we might address them in a diverse range of ways. And frankly, if you can't beat them, join them. Thank you very much.
And don't forget to subscribe to our YouTube channel for the latest lean content.